Okay, well, we're going to be talking about solving inequalities using addition and subtraction. Okay, so the objective is to use addition and subtraction to solve inequalities. Okay, and our standard is A1.2.5, same as what we had before. Okay, key concept, the first key concept we have is let A, B, and C be real numbers. If A is greater than B, then when we add a C to both sides, it's going to remain the same. A plus C is greater than B plus C. So very much the same as equal signs. Okay, if you do it to both sides, everything stays the same. If it's the other way, A is less than B, same thing applies. A plus C is less than B plus C. And this holds true for less than or equal to or greater than or equal to. So for an example, if we were to say like 5 is less than 8, that's true. Yeah, 5 is less than 8. If we add, let's say, 4 to both sides, we get 8 plus 4 on the other side. That's 9 is less than 12. So it's still the same thing. Okay, it's still a true statement. So as long as we do it to both sides, nothing changes in the inequalities. Okay, so using the addition property of the equality is in problem 1, part A. We have x minus 15 is greater than negative 12. We want to get this x by itself. So we got to get rid of this part where we're subtracting 15. Well, we do that by adding 15. Okay, adding 15 to both sides. So once we do that, we have x minus 15 plus 15. Well, that just cancels to give us x is greater than, and negative 12 plus 15 is 3. Okay, so the same thing applies there as we go through. X is greater than 3, and then we want to graph that. So we go to our number line, we put 3 in the middle, put an open circle on that. You put 4 and 5. Over here we're going to put 2 and 1. And letter, symbol, number, we're going to shade to the right. Okay, and always we want to check our work. So how do we check our work in inequalities? Well, simple enough. All we do is pick a number. So 5's over here. So let's take 5 minus 15 and see if this statement holds true. So all I did was take the original problem, x minus 15, and plug in 5 for x. 5 minus 15 is negative 10. Is negative 10 greater than negative 12? Yeah, that's closer to 0, so it is greater than. Okay, part B is what are the solutions of x plus 9 is less than 12. Okay, so I want you to go ahead and think about that as, well, we're kind of preparing for the next thing. It's addition of 9, so how do we counteract that? Oh, up here it was subtraction, we added, so we're going to subtract 9. Okay, we get x is less than, and 12 minus 9 is 3. So again, we go to our number line. We put the 3, we put an open circle, put 2 and 1, and then 4 and 5. But in this case, it's saying shade the other direction. So we shade that way. And then we do check the same thing. 0 is over there, so let's try 0 plus 9 is less than 12. Is 9 less than 12? Yep, that's a true statement. So both of these work out. Okay, so this part B leads us into the next thing, which is the key concept subtraction property. Well, as you notice, everything worked out the same way. So whether I add or subtract, it's going to work the same way. If I say 10 is greater than 7, true statement. But if I take 10 minus 3, that is the same thing as 10 or 7 minus 3. That makes 7 is greater than 4. Still a true statement. Okay, and again, these each all work for greater than or equal to or less than or equal to. So let's look at these problems. What are the solutions of 7 is less than or equal to x plus 3? Okay, well, we'll do this first one together, then I'm going to have you do the other one on your own. We're going to subtract 3 to both sides, just like we did before. You get x is less than or equal to there, and 7 minus 3 is 4. Okay, so in this case, we have 4 less than or equal to x. Let's switch this and make that x 4, which means arrows pointing to the 4, so we got to point that arrow there. So we got to make this number line, and we're going to say 4 there still. We put 5 and 6, 3 and 2. We have a closed dot on 4, but we're going to shade this way to the right because it's saying go to the right. Okay, part B, go ahead and do on your own. Okay, see if you can do that. I'm going to check that in your notes and we'll go over those in class. Okay. Example 3 here says that you have an Xbox that holds 250 gigabytes. You have downloaded a few games and various apps. You have used 120 gigabytes so far. You would like to download a few new games this Christmas. What are the possible sizes of the games you could download? Okay, so in this problem you want to think about what you have. You have a total, so 250 is the total. So let's say it's equal to, well, let's take, we already used 200 or 120, so we could add to that. Well, we could add how much more? Well, let's put D for downloads. Okay, so 120 plus the new downloads can only equal 250. Okay, otherwise you're out of space. So now we go and set up our inequality. Okay. Well, we don't have to use all 250, so we can use, this is our use, less than, or we could use all of it. Okay, so that's how we set up the inequality. We think of it as an equals. How do we make this equal? And then we say, well, we don't have to use all of it, so there was our setup. So now all you have to do is subtract 120 to both sides, just like before, and D is less than or equal to 130. So there would be our solution, 130. And again, you could check that. So what happens if we used only 40 more? You would have 160 is less than 250. So you just pick a number out and set that up. Okay, so again, hit up the discussion board. Let me know if you have any questions. On top of this, what I would like for you to do is on the Algebra 1 webpage, make sure you click on the chalkboard. There's going to be a mini assignment. So just about 3 or 4 questions over this lesson that I want you to complete before you come in the next day. So that needs to be done before midnight tonight. Okay, have a good night.